I'm just so tired. It's like we need reinforcement. We could call Kaiser.
Kaiser! Hi, this is Mrs. Kaiser. I'm your guest teacher today. So we're going to start by going over your warm-up that you should already have done. So what we have here is the sine function from 0 to 2 pi drawn in, and now we need to draw it in from 0 to negative 2 pi. So the pattern here is we've got 0, high, 0, low, 0. So we're going to do that in the reverse direction. So we've got 0, low, 0, high, 0. How'd you do? Hi, me again. Are you ready for warm-up number 2? So on this one we have the cosine function. And so we already have the graph done from 0 to 2 pi. And remember, cosine cup up. So it's high, 0, low, 0, high. So now we're going to go back and do that in the reverse direction from 0 to negative 2 pi. So we've got high, 0, low, 0, high.
Hey, thanks, Mrs. Kaiser. How'd things go?
It went well. Thanks a lot. That was fun. Do your homework.
All right, so we have done reflections and we've done dilations of sine and cosine graphs, but we haven't yet started translating them, moving them around, shifting them up, shifting them down, side to side. So let's kind of see how that works. We are really good at these. We've done this in almost every unit, started shifting things around. So let's start with this guy, y equals sine of x minus pi over 2. Now x and theta, they're interchangeable, so don't stress about this now saying x. So the parent function here would just be sine of x, so y equals sine x. So we know the pattern points for that one. We start 0, we go high, we go back to 0, we go low, we go back to 0. So we could get that on our graph, but let's see if we know our transformations first. So the only difference between these two functions is this minus pi halves inside. So inside makes us think, okay, it's moving left, but inside opposite. So that minus pi halves is actually going to be a translation to the right. So over here, I'm going to say translate. So translate right pi halves units. Now, when we're talking about periodic functions, this is actually called a phase shift. Okay, so now that we know what our translation is, what we're going to do first is we're actually going to graph the parent function. Now, I'm going to do this in another color, and we're actually going to dash line this graph because it's not really there. It's just going to be there to help us know where to move the new graph. So sine is our parent function, sine x, so we start at 0. We went high, back to 0, low, and then ended at 0. So now we're going to go ahead and perform the translation. So pi halves, this is the length of pi halves right here. So when I shift my parent function to the right, pi halves units, that's how far I'm shifting. So pi halves is worth 1 tick on my axis. So if I'm going to do that, I'm going to take all of these pattern points and I'm just going to move them pi halves to the right. So this first pattern point, move it to the right, pi halves, so then it's going to be here now. Notice I've switched colors back to my original color. So I'm going to go ahead and cross off that point that I just moved so that I remember it's not there, okay? This is just me keeping track of where I'm moving. So then this one, shift to the right, pi halves, so there I go, cross it off. This one. Now this one would hop off the graph. So if I were to connect these, now I have this sine graph that's been moved, but I know that this graph goes on forever. So I'm going to go ahead and continue my pattern points before I connect this into a sine graph. All right, so I have filled the whole set of axes, and that's what we're going to want you to do for these. We want to see the whole graph, so make sure you're graphing all of those points, and now we're just going to connect them, being really strategic about making sure we have our concave up look, our concave down, concave up, concave down, and concave up. Boom, y equals sine of x minus pi halves. All right, so we have our graph, so now let's go ahead and see what we know about it. So the domain, like I said before, this is graphs going on forever. It's going to keep covering all of our x values. So we can say our domain is all real numbers, or if you want to write that in interval notation, negative infinity to positive infinity. All right, the range. The range is, what y values we're covering. Well, our very bottom of the graph is at -1. The very tippy top is at 1. So we're going from -1 to 1 inclusively, or we could write that as -1 to 1 in brackets. min and max values. Well, remember mins, those are the, the very bottom of our graphs. So the valleys of our graph look like these little guys here. There's multiple of them. The value that they're at when we're asking for min and max values are the y values. Well, the minimum y value is -1 at multiple locations. So when I give my min, I'm gonna just say min of -1. Usually we would say at and list all the x values. There's gonna be too many to list, so we're just gonna say of -1. Same with our maxes. Maxes look like mountains, they're up here. So we have the max at 1 repeating over and over again, so we're just gonna say max of 1. Okay, so let's try a cosine translated graph. So cosine parent function, y equals cosine x. Inside we have a plus pi, so inside opposite, so that's gonna translate us to the left pi units. Remember, that's also called a phase shift, left pi units. And then outside we have a -2, so we're gonna have a shift down as well. So let's get these written. Okay, so before we perform our translations on our graph, we're gonna go ahead and graph the parent. So the parent function, we start, cosine, cup, so we start up. And we start up, we go 0, low, back to 0, and we finish up for 1 cycle. So this would be my dashed line graph because it's my original parent that I'm gonna go shift around. Now something I'm missing here are labels. So if this is my original parent graph, we know it ends 1 cycle at 2 pi. So I'm gonna go ahead and label from 2 pi to -2 pi. It's not realistic to think our graphs are always gonna be labeled for us. So make sure you're getting in that habit of labeling. So if I know this is 2 pi, half of that would be pi, half of that would be pi halves, 1 pi half, 2 pi half, 3 pi half, okay? And then I'm gonna go do the same thing on the negative side. All right, so let's start shifting around. So I've got my points, so these are gonna be the points I start to move. So I'm supposed to move left pi units and down 2 units. Well, what does it mean to move left pi units? Okay, before we were only moving by pi halves, so that was 1 tick, but pi is 2 ticks. So if I wanna move each point to the left pi, I'm gonna have to go, okay, well that's left pi halves, so that would be left pi. So pi is gonna be worth 2 ticks on my labeled graph. So be aware of that. So first point, left pi units, and then I'm supposed to go down 2 units. So if I start shifting these points, they're gonna start floating and it's gonna get messy. So it'd be nice if I had like an anchor for where my points need to end up. So what we can do is we can actually go back to the parent and look at what we call the midline. The midline is a horizontal line that breaks up your graph in half between the max and the min value. So in this case, my midline is my x-axis. So if I know I'm shifting down 2 into the left pi units, the shifting left isn't going to do anything to my midline, but down 2 would move my midline down 2. So I'm going to go ahead and graph a new midline. That will help anchor my new points so that I know that, okay, well this used to be on my old midline, so this point, wherever it moves, it's going to be on my new midline where it ends up. Okay? So let's start shifting. So I've got this point, left pi units means 2 ticks, and then we're gonna go down 2 units. So down 2 units is gonna make it end up here. Now we have a lot of points we're gonna be shifting, so I'm definitely gonna cross off points as I shift them so I don't accidentally shift them twice. Okay, so this next point, left pi units, so 2 ticks, down 2. And look at that, it ended up on my midline just like it was on the old midline before. So cross that point off, left, down 2. Okay, so I've shifted my 5 pattern points, so I now have this cosine cup shape right here. Now, I'm not gonna connect it yet because that wouldn't look right, just this random cup shape floating in the middle of my graph. We know we're gonna draw it from -2 pi to 2 pi. So I'm gonna go ahead and continue the pattern. So if this was high, then the point before it would have been at 0. The point before that would have been at low. And then same with this one, this is high, so the next point's at 0, and then low. Then we'll connect. Concave up, concave down, concave up, concave down, concave up. Boom. Look at that killer graph. All right, so let's go do the domain range and identify our mins and maxes here. So for domain, we know it's going on forever, so we've got all real still. For range, since we've shifted down, we're not gonna be -1 to 1 anymore. We've shifted it. So my max value is at -1, my min value is at -3. So I'm bouncing between -1 and -3 for my range. So I'm gonna say -3 to -1 inclusively, or you can list it. Okay, -1. Okay, and then like I said, our mins are at -3 of -3. Max values, like I said before, is at -1. So, of -1, yeah.
Y equals 2 sine x plus 3. All right, well, that means our parent function is still y equals sine x. You write the translations. Okay, so the 2, we have a vertical stretch by a factor of 2, plus 3 at the end, translated up 3 units. Now, I'm going to go ahead, this doesn't have a shift left or right, so I wouldn't recommend this in most cases, but just kind of know yourself. I'm going to go ahead and think about where that midline is going to be. Typically, we are at y equals 0. But now we have translated up 3 units. So I have my midline going up 3 units. 1, 2, 3. So I'm going to go ahead and sketch the midline. So then I need to think about the pattern points and the fact that I have a vertical stretch by a factor of 2. But I'm going to go off of the midline. So starting here, we know that typically sine is 0 when x is 0. But it's moved up 3 units. So I would be here. And then I would go, whoa, 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 we need to mark our axes. Yikes. So just to review, if I start here at 0, which it's not 0 because it's been translated up 3 units, but I would go high, back to the midline, low, back to the midline. Vertical stretch by a factor of 2. So when I get to pi halves, I'm actually going to go up 2 units from the midline. Then I'm at pi, I'm going back to the midline. I'm going to go low at 3 pi halves. The low that I go is 2 units down because of that vertical stretch. So I'm going to go down here, and then at 2 pi, back to the midline. All right, we need to finish out the pattern points. I have from 0 to 2 pi, but what about this side? So -2 pi to 0. Well, I'm here at the midline. I was high, so midline back to low, which is going to be at that, down 2 from the midline. Then we go back to the midline. Then we're going to go high 2 units from the midline. So, and back to the midline. Here we go. Concave down. Boom. At that midline, we change to concave up. Boom. Concave down. Concave up. Kind of missed that guy. Whoops! Okay, go ahead and try domain, range, min, and max. Let's talk about the range. How low can you go? How low can you go? How low can you go? That's going to get cut out, right? All right. So the lowest point on the graph is here at 1. We're talking the y coordinate, and it goes all the way up to 5. And then, of course, from the range, we can see that the min, we have a min of 1 and a max of 5.